is actually my favorite way to graph parabolas. I love it. It's my favorite way. I don't love doing the axis of symmetry. You can do it, but it's an extra equation, right? You guys found that out yesterday when we were graphing like ax squared, and there might have been something on the end, right? But our axis of symmetry was always on 0. And like Megan said, it's like what we've been doing, but it was easier, right? So this is what is called vertex form. Please remind me what the vertex of a parabola is. The highest or the lowest point. Yep, the highest or the lowest point. And so when we are in this form, and the more we do with it, the friendlier it will feel. We know exactly where the highest or lowest point is. I don't have to find the axis of symmetry, and I don't have to plug it back in because it tells me, okay? Now what you need to know is the K moves our vertex up and down. The H moves your vertex left and right. But this one is tricky because of this minus right here in the formula. You always have to go in the opposite direction of the sign. Always the opposite direction. And so sometimes we get confused with which one is opposite. It's always the one in with X. What would you have to do to get the X alone? So it's always the opposite direction. And this number in front of the parentheses stretches or compresses the shape of your parabola. And that's a fancy way of saying it makes it really skinny, or it might make it open very wide. So it changes the shape. Now you guys know, because we've done it several times already, what our parent function looks like. If there's no B term, what's my axis of symmetry? We did that yesterday. Right here on 0, right? And our vertex ends up being on 0, 0. All right, so we're going to graph f of x equals 1x squared. So plug in 1. What do you get? 1 squared is 1. Balance it on the other side. Plug in 2. What do you get? 4. Balance it on the other side. Okay, there is our parent function. Now that we know what our parent function looks like, we're going to move it around. Okay? Still see some note takers, so I'm giving you just a second. Okay. Do you recognize the x squared? Is that what we graphed just a second ago? Yeah, for sure it is. It has a +2 on the end of it. What does a plus number on the outside do? What does it do? It says it moves it up or down. So this +2 moves my parent function up 2. So without doing any math other than counting, instead of right here on the 0, 0, like this guy up here, where am I going to move it? Up 2. 1, 2. And then it's the over 1, up 1, over 2, up 4. I like shortcuts. I don't know about you guys. I think they're divine. All right. Am I giving you enough time? Not enough time. All right, next one. Inside with the parentheses is the minus 3. Kind of like this minus h up here. Moves it left or right. If it says a minus 3, I told you always opposite. So what direction are we going to be going? We're going to go right 3. So we're going to take this parent function up here. Instead of sitting on 0, 0, where am I going to move it? Right 3. And then it is over 1, up 1, over 2, up 4. Yes, sir.
What if that has a K?
Has both?
Yeah.
We'll do that in just a second. In fact, I think I want to change this problem, you guys. Which one do I want to change? That one does both of them. We'll wait a second. Okay, I have an A term, and so I'm either expecting it to get skinnier or to get broader, right? And I don't know which one. Is there any left or right? Is there parentheses? There's no left or right. Is there a plus or minus anything outside? No, so there's no up or down. So I know it's going to sit right there. And today, I think we're going to plot points for these when we have an A term, and then I'll push you to the shortcut tomorrow, next time we talk about this. All right, so I know where my vertex is. It didn't move up or down or left or right. This 2 does crazy things, though. Plug in 1. What do you get? 1 squared is 1 times 2 is 2. So instead of over 1, up 1, it was over 1, up 2. Let's plug in 2. 2 squared is 4 times 2 is, so over 2, up, it's probably going to go off of this. 1, 2, 3, 4, 5, 6, 7, 8. Balance it on the other side. Does that make it skinnier or broader? Skinnier. Okay, let's do this one. Where is my vertex? Does it move left, right, up, or down? Nothing. There's no plus or minus anything out here, right? So it's going to sit on 0, 0. All right. You guys okay with plugging in 1 and 2? Seem like friendly numbers. I should have created a table over there a second ago. If I plug in 1, what do I get? 1 squared is 1 times half is half. Let's do 2 while we're here. 2 squared is 4 times half is, all right, let's plot those. Over 1, up half. Reflect. Over 2, up 2. Reflect. All right, Brady, you asked me a question a second ago, and now we're there. Sorry? Okay, where is my vertex? What does this plus 1 do to my vertex? Plus something. It moves it up. How many? 1. All right. There it is. Should we use 1 and 2 again? They seem to be our best friends. Okay, I'm going to do them right here so I have room. X, Y, 1, and 2. Okay, this one's going to be a little harder, right? I've got to think about it. 1 squared is 1 times negative half. 1 times negative half is negative half. Plus 1 gets me back to half. Could you use your calculators to do that? Yes. Let's plug in 2. 2 squared is 4. Negative half of that is negative 2 plus 1. All right, let's plot those and reflect those. Over 1, up half. Wait a minute, why is it below? Ah, I've got a negative function, so I expected it to open down. Hopefully you saw that. Over 2, down 1. Is this better than finding the axis of symmetry? I think it's better than finding the, Tyler likes finding the axis of symmetry better. All right, this does 2 things. What does the minus 3 do to our vertex? Moves it down 3. How about that minus 1 inside the parentheses? Right or left? Always the opposite direction. Yeah, so this is going to be a right one. And that's hard to remember. So down 3. So from the origin, we're going to go down 3. And we're going to go right 1. Now, if we're going to do a table, can I pick 1 and 2 again? I've got to move to the side of my vertex, right? I'm already on 1, so maybe I should pick 2 and 3. I like it. 2 and 3. Now, I'll use scratch paper on this so we're not doing it in my head so we can see this one a little bit better. All right, so 2 times 2 minus 1 squared minus 3. 2 times 1 squared minus 3. 2 times 1 minus 3. 2 minus 3, I get negative 1. All right, let's do that for 3. 2 times 3 minus 1 squared. 2 times 2 squared minus 3. 2 times 4 minus 3. 8 minus 3, I got 5. Plot those points and reflect them. 2, negative 1. And what is that, 3, 5? And there's our beautiful parabola. So it's just another way of looking at graphing quadratics. And being able to find the vertex quickly makes this a little shorter than the other standard form. Your assignment should be open on Alex.